Hello, my name is Kerem Ege, and I'm an assistant professor at INSA Lyon in the mechanical engineering department of INSA Lyon. I am conducting my research at LVA, Laboratoire Vibration Acoustique. It's a pleasure to participate to this musical acoustics in education session of the eForum Acousticum 2020. I will present to you today the project in musical acoustics that we developed and supervised at INSA Lyon since 2017 with Julien Colmars, a colleague from LAMCOS, assistant professor on the same department. So this presentation is entitled Musical Acoustics as Learning Support for Engineers, and we'll give some example of student achievements at the department. So here is the summary. The context and motivations will be given for these projects. And we'll focus on the main question, why musical acoustics projects in a mechanical engineering department? The proposed teaching approach from Julien Colmars and me, these are two questions, two main questions: how to formulate a musical acoustic issue and how to present these results. It's very important with a report and oral presentation. We'll give some results of past studies, and we will conclude and give some perspective for future. Of course, here I precise that you will find the name of all the students that have chosen these projects at the end of the presentation, and also on the proceeding online on the website of the conference. And we thank them for having accepted to give us the possibility to reuse part of their work here. So let's begin with the context and the motivation. In September 2016, the educational provision for GM department, Génie Mécanique department, mechanical engineering department at INSA Lyon, it has been reviewed and updated deeply in September, in this date, 4 years ago, after the merger of two old departments. New scientific and technical project PST has been built, Projet Scientifique et Technique in French. These projects are in pairs of students, 40 hours on classroom plus an equivalent work at home. And we insist on the abilities of thinking, analyzing, well-defining, resolving a given scientific problem. There are two teachers that supervise this. Here are some examples of studies proposed by colleagues very rapidly. For example, numerical simulation of dexterity games or modeling of a Jacquard machine. Here are some material choice for a given engineering problem. Here is an interesting development of moon landing mission or design and production of golf ball launcher. And for us, Julien and me, we propose some musical acoustics project in this PST. We believe that it's a perfect theme for multidisciplinary approaches. It's a good way to give motivation to our students. It can offer a good variability of projects from year to year. Here are examples of studied instruments during these 4 last years, all the family of instruments, as you can see. And the projects can fit students' background at this time of their education. It's very important this. They will need some courses of linear mechanics of continuous media, classes of computational methods or signal processing. So this was important also. So main question, how to formulate a musical acoustic question and a scenario to answer to it. A general frame given to students is pick an instrument, define a question that could be answered with the help of experimental, numerical, theoretical work. And the first session are directly dedicated to this definition and to the clear exposure of a scenario to answer to this question. So the first reaction of students can be very different, and they depend on their musical education or curiosity. They can be very happy, they can be doubtful. What is sure is that most of them usually don't have any idea of physics, of the physics behind the musical instruments. But after 1 or 2 working sessions, they are enthusiastic on the given instrument found on their environment, family, friends, and they start to imagine some experimental measurements, numerical simulations. And it's a really good opportunity for them to build this issue on their own, and we insist very regularly on making them verbalize. after 5 or 6 sessions, we can say that the problem has been clarified. So each year, 6 different projects, and there is a small budget at INSA for that. But we encourage them to use some sensors hidden on smartphone and also some small setups in INSA's labs. Here are some examples of a question subject that has been studied these last years. So after several iteration loop session, for example, a question on the vibraphone here, how to optimize the Metallophone bars for given model resonance series. Another question on guitar, what's the influence of the sound hole on the vibroacoustical feature of the instrument? Another question on the drum, how to model the snare wires here of a snare drum. Question on the, for example, hollow body guitar, what's the influence of the top plate vibration on hollow body guitar? Or the question, for example, mouthpiece and reed parameters, what are the influence on the clarinet sound? Here another subject on the influence of the player on the classical guitar sound, or how to model the wolf tone on the cello. So what about a simple model for the cajon? And the last question here presented, what choice of material for the different parts of a classical guitar? So Julien and me, we encourage students to use some tools to define these scientific questions. One tool that we can think to is mind maps or diagram schematics. Here, for example, from students on dealing on the grand piano, is a sort of mind maps that they did to help them to define the question. Sorry, it's in French, but it's an example here. And we also help them to begin their work, their bibliographical work, which is very important. And we encourage them to have a look, to read part of this very well-known book of Antoine Chaigne and Jean Kergomar, Acoustics et Instruments de Musique. Also to have a look to this nice website developed at UNSW, New South Wales, Australia, by the team of Joe Wolf, with very well-made animation, sounds, video. And also to use some tools such as the mind mapping tools for physical classification of instrument through these typical mind mapping tools. How to present results in a scientific report and oral presentation. We encourage them to write technical reports in 5 pages maximum, double column. Something very similar to the scientific proceedings article, to focus on the main results and to work on the quality of figure, diagrams, tables. So we gave some tech or doc templates. Here are some examples of a quite nice report in the mechanical engineering department. And at the end, there is a final oral presentation, quite similar to a conference format. The softwares, these are student affinities. Some students like to use some free software, such as Audacity, for example, for audio measurements, but also they can use their smartphones. The post-processing, signal processing using MATLAB, or data is video processing also using other types of softwares, Lattice Pro, for example. And here are some other softwares for computer-aided design or FEM, BEM. I won't enter too much into details, just to show you some sorts of results that it can obtain. So now, some studies and results from students. First one is the shape optimization of Metallophone bars. Here you can see that the students wanted to optimize the shape of Metallophone bars in order to obtain some harmonic series. Here are, for example, what they want to have, 136 for first model resonances, or 148 or 141. Using a Newton-Raphson algorithm on this geometry, they can find the optimized shape, the optimized geometry of the Metallophone bars. They used water jet cutting machine to cut these bars in steel. They measured it, vibrations, and it works. So it has been validated. It's quite a nice project. It works. They obtain exactly the same resonances that they wanted. Another project on the Helmholtz resonator of the guitar sound hole. You all know that this sound hole can behave like it behaves like a Helmholtz resonator, and they can show that if you close this sound hole, you lose 30 dB in the low frequency domain. So it's very interesting. And if you go on this website of UNSW, you have some basic research on that, and they were using this website. And here another result from them. If you excite a G sharp 2 note, you can see that if you close the sound hole, you lose 30 dB in the low frequency. Another subject, another result on vibroacoustics of a cajon. It's a measurement of the impulse response of the cajon using 2 microphones and a loudspeaker. Very interesting. You can see some top plate resonances here. Here is the Helmholtz, a very low frequency resonance that they can measure, and also the back plate. Here is the back plate first resonance. And the last results showing today is the choice of material, measuring some wood species, the tone wood comparison on the Young's modulus loss factors on different species using here a piezoelectric sensor directly on the smartphone's jack plug. So it's quite interesting measurement, and it's possible to measure on free flexural vibration that beams vibrations. So to finish, students and teachers, the teachers also developed collaboration during this project with luthier instrument maker in Lyon, also La Maison de la Corde, linked with Laurent Vallée. We also bought some wood of Bernard Michaud au Jura. It's bois de lutherie, it's tone wood. And we also developed some collaboration with teachers and students from the Conservatoire de Lyon, Conservatoire National Supérieur de Musique et Danse de Lyon, from the music studies section also of INSA Lyon. And the students, they also sent some mails to researchers, mails, discussions, and they asked some advices with colleagues also from the SFA GSAM group, groupe scientifique d'acoustique musicale, groupe spécialisé. To conclude, we gave an overview of the scientific and technical projects of GM department, where the musical acoustic subjects are proposed. The mechanic of musical instrument covers the whole physics, and you can see that the number of scientific questions that can be formalized are endless. It was a good opportunity for students to build a scientific issue on their own during these projects, and it interests students and develop their curiosity. Some perspectives are for these projects. The musical acoustics teaching may be increased at the department, maybe, not only during projects, and we can also increase local collaborations with luthier instrument makers to give them a support, maybe through small students project at INSA, to answer questions, difficulties they have, analytical, numerical modeling, or measurements. And I want to finish with, of course, we're grateful to all students that have chosen this project. And we thank in particular the students hereafter for having accepted to give us the possibility to reuse part of their work. So thank you for your attention, and I'm available to answer to your questions.